7 through 10. So let's go ahead and let's check over. So, number 7. What are the cord-like structures that connect skeletal muscles to bones? So this is muscles to bones. That is a tendon. Remember, a ligament is bones to bones. So for this one, if it's a muscle to a bone, this one is tendons. Number 8. Which type of muscle functions whether you think about it or not? Those are involuntary muscles. Voluntary muscles you can consciously control or move them if you think about them. Some of them, they go whether or not you think about them, and that's a good thing though. We'll talk about the reasons why. Number 8. Oops, sorry, number 9. We're already number 8. Number 9. Name 2 major divisions of the nervous system. You have the central nervous system. Your book starts to abbreviate that as CNS because it's tired of giving the full term over and over and over again. And then you have the peripheral nervous system, or the PNS. So if you wrote CNS or PNS as your homework answer, all right, but you want to note the full terms as well for it. So don't just go off of, okay, here's the abbreviation. You need to know the full terms for it. Number 10, what part of the brain controls automatic activities such as breathing and digestion? That is your brain stem. We'll talk about the 3 parts of the brain later on. Just note for right now, it is the brain stem. All right, you can go ahead and put your homework away. Take out a piece of paper so that way you can work on your classwork. So again, because we can't spend a lot of time playing review games together, I need you to use your time properly in class. That way you are still reviewing as part of your class time. So I've labeled this skeleton 1 through 15. You want to try to label as many parts as you can without looking. First off, don't use your textbook. Try to label as many parts as you can for it. Try to go through it as quickly as you can, but you want to try to see which one is which as fast as you can. Once you do that and you get completely stuck though, then you can go ahead and take out your textbook and then finish labeling them. So there's 15 bones that you need to know. These are the ones we went over yesterday. So you want to try to label them as best as you can. If you get completely stuck though, then go get your book and copy those out. I'm not going to leave this slide here for long, so you're going to have to pause the video and then come back and unpause later. So you want to try to label as much of it as you can without looking, but then go back and copy down the bones, label the skeleton 3 times. So it'll help you to start memorizing which bones are where, and you need to know that. So at this point, you want to pause the video so that way you can work on that. Or if you're trying to live stream with me, which I see someone is, so if you're trying to live with me, you probably want to come back later or finish that later so that way you can still get your class time because I won't have time to wait for you all to go ahead and to work on that. But make sure that you do that because it'll help you to study and it'll help you to use your class time properly. Alright, so let's go ahead and ask some review questions. So I'm just going to ask some questions and then I'm going to pause and hopefully you can answer. If you want to try to answer out loud, now I know if you have siblings around that's kind of weird and kind of creepy, so you might not want to do that. But at least try to answer in your head as best as you can, so that way you can try to figure out what the answer is before I say it. So I'm going to move kind of quick though. Alright, so thinking about your integumentary system, what is the major organ of your integumentary system? Alright, hopefully you said skin, so make a note for that. So again, as you're going through these, you want to have a piece of paper so you can write down any term that you don't know, so it'll help you to focus your time so you can study them, so you'll be ready for your quizzes that are coming up in the near future. So make a note, skin is the main organ of your integumentary system. There are 3 layers of your skin. What are they in order going from outside to inside? So if you're looking at someone, and if you get a cut going through those layers of your skin, which layers do you go through? Alright, it's epidermis, dermis, and then subcutaneous. Remember, you want to give that better term, so subcutaneous. Which layer is the layer everyone can see? It's made up of dead cells. Good job, it's the epidermis. What is the layer that's that bottommost layer? It has your major blood vessels and the adipose, or fat tissue. It connects your skin to your muscles or bones. Right, that's the bottom layer, that's the subcutaneous. What's the middle layer then that has your nerve endings and some of your minor blood vessels? You'll start to bleed if you cut this. Good. The dermis. What's the major pigment, the brown pigment of your skin? There's other pigments, but which one is the major one that determines how tan or how dark colored you are? Good job, melanin. Alright, thinking about your skeletal system, what's the purpose of your skeletal system? Hopefully you said to provide your body with rigidity or support. So make a note for that, that's the purpose of your skeletal system, so you're not like a jellyfish or a piece of jello on the ground. What is the soft fatty tissue that produces the red blood cells in the center of your bones? Good job, that's the marrow. Make a note for that. There are 4 different types of bones. What are they? Perfect. Long bone, short bone, flat bone, and then a regular bone because it doesn't fit in any other category. Alright, what is the 2 major divisions of the skeletal system? We talked about this yesterday. So there are 2 major divisions of your skeletal system. What's the one that's more of the center of the straight line, basically from your head going down to your tailbone? What is that straight line one? Axial, perfect. And then what are the ones that are your appendages? So your arms, your shoulders, and your legs and hips. Appendicular, good job, sounds like appendages. Alright, thinking about the parts of your skeleton, we're going to use a diagram so it'll help you out. So again, if you didn't label this, make sure you go back and you label it later so that way you're getting practice with it. What do you call, alright, so this is your skull, obviously, but what do you call the back part of your skull? It helps, it protects your brain, has the brain on the inside. Cranium, that's it. What do you call the bones that form your upper jaw? What do you call those? Maxilla or maxilla, you're talking about both of them at the same time, that's it. What do you call your jawbone, the bottom one? This is the one that can move. Mandible, perfect. Alright, this number 4 is pointing to your collarbone. So right here, it's a little hard to tell in the diagram, but it's pointing to this collarbone. What's the technical name for it though? Clavicle, that's it. Alright, number 5 is pointing to your shoulder blade. Now on the picture you can't tell very well, so if you were a little bit confused by that, I'm sorry. I tried to do the best I could. But what do you call your shoulder blade? Scapula. Alright, what do you call this bone right here for number 6? What is this bone called in your arm? Humerus, that's it. Number 7 is pointing to your breastbone. So this bone going down the center of your chest, what is that one? Sternum. Alright, number 8 is pointing to all of these bones that help protect your chest and your vital organs. So what do we call all these bones? Ribs, that's it. Number 9 is pointing to your backbone, but what's the technical name for your backbone? Your vertebrae or your vertebral column. If you're talking about all of them at once, as vertebral column. If you're talking about an individual bone vertebrae. So just make a note for that. Number 10, what do you call the fused vertebrae that help support your hips? They're part of your hips. Sacrum, good job. And then what do you call the sacrum? Sorry, I pronounced it wrong. Sacrum. What do you call the tailbone? That's what number 12 is pointing at. It's a little hard to see. Good job. So it's the tailbone or the coccyx. So make a note, technical name for it, coccyx. Alright, I think I skipped number 10 by accident. I jumped to number 11. So number 10, what do we call these bones right here that are your hips? Pelvis, that's it. Alright, 13, what do you call your fingers? What are those bones in your fingers? Phalanges, perfect. Number 14, what do you call this long bone in your legs? This is also, as a side note, the longest bone in your body. Femur, perfect. And then number 15, what do you call the bones of your toes? Phalanges again, good job. So those are the same, we call it the same name for your fingers and for your toes. Alright, I kind of skipped over this yesterday, I referenced it really quickly, but what do you call the hollow spaces in your skull that resonate to give your voice this distinctive quality? What do we call those hollow spaces? We talked about them on Friday, but I skipped over them, yesterday by accident in the review. What do you call those hollow spaces? They're kind of up around your nose area. If you have a cold or allergies, these might be irritated right now. Sinuses, so just make a note for that. So sinuses, those are the hollow spaces that help your voice to resonate, and they also lighten your skull, so your skull's not too heavy. Alright, other things that you need to know. Alright, what connects bones to bones? What's that tough kind of cord, connective tissue? Now it's bones to bones. Ligaments, good job. What do you call the place where 2 or more bones meet? Like at your elbow, or in your thumb, or in your knee? What do we call those points whenever you have 2 or more bones meet together? Just a joint, good job. Some of them are immovable joints, but you also have a lot of movable joints in your body. Alright, there are 3 different types of movable joints that you need to know. Alright, what's the one that swings back and forth? So just an up and down or a back and forth motion. You have this in your elbows and in your knees are the main areas for us. They just swing back and forth like a door on the hinge. So what type of joint is that? Hinge joint. What do you call the joint that allows your bones to have a turning motion? The major one that we need to know is in your elbow, so it allows it to spin. So what is that type of joint? That's a pivot joint, good job. And then what is the most freely movable joints in your body? They're in your shoulders and in your hips. They allow you to have a lot of movement. What do you call that type of joint? Ball and socket, perfect. Alright, we talked about, what do you call it, a break or crack in your bone? A fracture. Now there's two different types, a simple fracture and a compound fracture. If it's a simple fracture, what does that mean? Perfect, it means that it's not coming through your skin, so you can't see it. It might be broken, but you can't see it. Compound or open fracture means what then? It means that it's coming out of your skin and you need help. Go to the doctor. So make a note for that. So a fracture, there are two different types, simple and compound. Alright, that's most of everything that we've been talking about lately. Make sure that you've been studying on your own as well, so that way you are getting ready for the quizzes or tests that are coming. Spend your time focusing on it, so that way you are ready for anything that comes your way. This is the last thing that we pretty much looked at yesterday, looking at a simple or a compound fracture. So make a note for those. So a simple fracture closed, compound fracture is open. We read about evolution out of joint. We talked about the bendable bones. So let's get into it with the next major system is your muscular system. So do make a note that the next major system is your muscular system, that these muscles, these are the ones that provide movement for your body. So the muscular system provides movement. So your book points out there are over 600 muscles in your body. About half your body's weight is muscle. So just because you weigh so much doesn't necessarily mean it's a bad thing, because muscles weigh more than regular fat cells. So just because you might weigh more after you work out or after sports, whenever your muscles are larger, doesn't mean that it's a bad thing. So your muscles are strong and sturdy, and they give your body movement. So make a note though that there are many different types of muscles in your body. Your book points out there kind of the major ones are the skeletal muscles. These are the ones you can directly control with your conscious mind. You can think about these and you can cause these to move. So if you're deciding to take up your textbook, which you should, and turn over to page 95, this is whenever you're thinking about using your muscles. Now you might not be thinking, okay, I need to pick up my book, and I need to open my book, and I'm going to pick up my pen. You just think, okay, I need to get out my book and get out my pencil or my pen. And then your body knows how to do that already. So that's part of the reason as to how come your skeletal muscles, though, they are considered part underneath your conscious control, because you're choosing to move them. Some of your muscles, they will go whether or not you think about them, but that's a good thing. We'll talk about those muscles a little bit later on. So skeletal muscles, these are the ones you can consciously control. Now, we also call these voluntary muscles because you can choose or volunteer to move them. So you are choosing, if you decide during class that you want to pause the video and go get a snack or go get water, be sure to come back if you do that. That's your decision. You decide, I want to go do something, or I want to go get something. Then you can decide, I'm going to go walk and I'm going to go get it. You are choosing to walk. Now, because you're older, you don't have to think about how to walk anymore. But that's the reason why whenever a baby is first learning how to walk, they have to practice and they have to learn how to walk. As you get older, your brain remembers how to do that, so you don't have to consciously think about it. You just do it at that point. Alright, muscles, they work in partners though. So muscles are like ropes. They can only pull, they can never push back. Your book has this diagram. We'll talk about how a lot of these muscles are paired up to where one does one thing and then another muscle does the opposite or pulls back the opposite. So it's like partners where they have to row together. How many of you have rowed in a canoe or a rowboat before where you had to work with someone? Okay, well I can't see hands raised, so hopefully some of you have. But you'll notice you'll know that if you're in a canoe, one person paddles on one side of the canoe while the other person paddles on the other side. If you both paddle on the same side, what's going to happen? You're going to go in a circle. And so because of that, you have to paddle one on one side and one on the other. And you have to work together if you want to go straight. That's kind of like the same idea. Your muscles have to work together. Alright, so as you're looking at this diagram, don't freak out. You don't have to memorize all the muscles. You will whenever you're in biology. So to help you out with that, we'll get you started out a little bit. So the only muscles that you really need to know, though, to kind of get you started is you need to note your shoulder muscle. So that's this one up in here. That's your deltoid. So make a note for that one. Your chest muscles, your muscles that you use to push something away from you, or if you're in basketball and you're passing the ball, or if you're doing push-ups and you're pushing against the ground, those are your pectorals. So that's your chest muscles up here in the top part. So make a note for those. Your deltoid, those are the ones in your shoulder that allow you to raise your arm out to the side. So that's this muscle up here. Now you only need to know two more. You only need to know your biceps brachii. So that's the full name for it. I know a lot of people just call it biceps, but you want to know the full name because you're older. So biceps brachii is this muscle up here. So if you make a fist and then pull your arm towards your shoulder, you'll notice your muscle will pop up. Now my muscle is not very big, but that's okay. So that's your biceps brachii. Your triceps is the partner for it. So that muscle is the one that helps pull it back down. We'll talk more about that one in just a second. Alright, so your book points out muscles are like ropes. They can pull, but they can never push. So your muscles, they can pull together, but they can't push back. Because of how your muscles are made, they can pull or tighten, but then they can't go back the opposite direction. They're not designed to do that. So they can only pull forward, but they can't push and go backwards. So because of that, God designed it so that there's a lot of basically separate ropes or separate muscles on the inside of your body to help pull or counteract each other. They're showing you your arm. This is a major way to be able to talk about it. So if you want to go over to page 96, you can. So you can look at this as well. Now, this is for your arm. If you want to pull your arm towards your shoulder, your biceps is the muscle that pulls your arm up like that. So that's why if you make a fist, it's easier to see. And then pull it back up, it makes your biceps show up a little bit better. So that's your bicep muscle. So once your bicep pulls though, it can't push it back. So it just pulls it and that's it. You have to use another muscle if you're going to pull your arm back down. So the triceps is the partner. It's connected so that way it'll pull your arm back down. And that's what it's showing you in this picture as well, that you have your humerus. You should note that bone as a side note. And so you have the anchor points for the biceps. Now they're not showing you the triceps in this picture, but the triceps are also anchored so that way it can pull your arm back down. A couple of terms you need to note for this is the origin point. That's the point that's a relatively immovable point. That's where your bone is attached to. So that's like the top of your muscle, and whatever it is moving, we call that point the insertion point. So if you're looking at the picture, this is the origin or the connection point of the bicep. The insertion is down here. Because your muscle is pulling your arm up, it's anchored up here in your scapula area, in your shoulder area, and it's pulling the bone up towards it. So that's why this is the origin or the starting point, if you want to think of it that way. And it's inserted or connected to the bottom part of your arm down here. Well, it's the bottom. When I say bottom part, I mean that it's the lower portion of your arm. It's about right here in your arm, so it's not all the way down at your wrist. But it's the idea of, okay, if you're talking about your whole arm, it's about halfway down, so it's the start of the radius and the ulna. So that's the insertion point. So that's whenever it's pulling it. Now the insertion is always pulled towards the origin. So like how your muscles can always pull, never push, that they're always pulled towards the origin point. So if you want to draw a little arrow in your book with insertion going towards origin, that'll help you to remember that the origin point, that's where it's anchored, or that's where it starts. Insertion is always pulled towards the origin. So make a note like that. So insertion is always pulled towards the origin. Alright, some of your muscles, they do your work whether or not you think about them. They just keep going. We call those involuntary muscles. They are found in your organs. They are found in the passages of your respiratory system, the digestive system, and the cardiovascular system. Alright, that's a good review. So thinking about, when we're talking about organs and the passages of the respiratory system, what's an organ in your respiratory system? Alright, there's a couple of things you could have said, but you could have said your pharynx, your larynx, your trachea, your lungs was probably the main one. So make a note for that one. So diaphragm technically is a little bit different, but that's a muscle that helps you to breathe. So just make a note for that one. Now that one's a little bit of a separate category, but it's the idea of your diaphragm will help you to breathe whether or not you think about it. So the respiratory system, the digestive system, what's an organ in your digestive system? Could have said a lot of things. So your esophagus, your stomach, your small intestine, large intestine. Those are organs of your digestive system and of your alimentary canal. Hopefully you remember what that term is specifically. Now remember, what do you call that muscle contraction in your esophagus that'll let you swallow, even if you're upside down? Not that you should be swallowing upside down. Peristalsis. Good job. So that's the reason why you don't have to decide, I'm going to swallow it. It'll push it down whether you want it to or not. Now you have to make the choice in your mouth to swallow, but it's going to do that muscle contraction in your throat whether or not you want it to, and it'll keep pushing it through your small intestine whether or not you want it to. That's why that's an involuntary muscle. All right, the cardiovascular system. All right, what's an organ of your cardiovascular system? The major one that does movement is your heart, so you should remember that's the cardiovascular system. The blood moves because of the heart, so I don't know if I would really consider those part of the muscles of your cardiovascular system. But your heart is a type of muscle, and so because of that, your heart will pump whether or not you think about it, which is good, because if you had to think about pumping your heart and telling your heart to beat over and over and over again, we would all die the moment we fell asleep. So it's good that your heart keeps pumping whether or not you have to consciously think about it. Now, you can get yourself worked up and with emotions and make your heart beat faster, but you don't decide and you don't tell your heart to beat over and over and over again. It does it whether or not you want it to. Alright, so we do make a note, we call those involuntary muscles, so just make a note for that. Alright, the nervous system, that's all you need to know for your muscular system. So just make a note of those 4 muscles that we talked about already. So your deltoid, your pectorals, your triceps and your biceps, and then the parts of a muscle. So make a note for those. Alright, moving on now into your nervous system. This one coordinates the activities of your body. This is also where the thinking portion, or the you part of your body is. So we think that your personality and your soul is probably in your brain. We don't know, we can't see that, but your conscious decision that determines your thinking, what you like, what you don't like, what's your favorite hobbies, what video games you like to play, all of that is part of your brain. So that's why your brain is really, really, really important, because that's where you, as a person, you make your conscious decisions from. Now, your book points out there are 2 major parts of your nervous system. You have the central nervous system, or the CNS, because your book gets tired of labeling it. So don't know it just as the CNS though. Know the full name, central nervous system. So kind of how like with the skeletal system, how there was the middle section, and then there was all of the parts that came off of it. So remember, what's that middle section of your skeletal system going from your top to your tailbone? Axial. And then what's the part of your part of your skeletal system that's your appendages? So your arms and legs, shoulders and hips? Appendicular. So this is the same idea, to where you have one line for your major part of your nervous system, and then all of the nerves, or all of the branches that come off of it, we call that another section for it. So the names are kind of nice for this one. So you have the central nervous system. That's like the axial portion of your skeleton. It's the center part. So you have the central nervous system. So that's the brain and spinal cord. There's only really 2 organs in that one, so that's nice. So you have your brain, and then you have your spinal cord. Remember, your spinal cord is housed in your backbone, or your vertebral column, because it's that important. Like how we looked at with Ted yesterday. But technically, whenever you're talking about your spine, we use this loosely, but whenever someone's talking about their backbone, technically, that's the vertebral column, or your vertebrae. If you're talking about your spine, you mean the nerves on the inside. Why do you think God designed it so your nerves are on the inside of your vertebral column? Right, to protect them as much as possible. Kind of how like your ribs help protect your heart and your lungs, that your vertebral column is designed to protect those really sensitive nerves. Because what happens if those nerves in your spine get broken or damaged? You might have known someone this has happened to. They can get paralyzed, or they might not can move parts of their body anymore. So that's probably the reason why God designed it, so that way these nerves have extra protection, protected on the inside of the vertebral column, trying to give them as much protection as possible. So that's the central nervous system. It's your brain and spinal cord. The peripheral nervous system, this is all of the nerve and nerve tissues called ganglia that come off the central nervous system. Alright, so if you're looking at this picture, you have the brain and spinal cord, and then you have all the nerves that come off of it. Those are the nerves of the nerve tissue called ganglia. We'll talk more about those in a couple of years in biology. Right now you just need to know, okay, that's part of the peripheral nervous system. You can remember peripheral nervous system because you might have heard someone talk about peripheral vision. That's the vision at the edges. Whenever you're looking straight ahead, because of how your eyes are located, you can still see at the edges of your vision. Even though you're not looking at it directly, you will still notice movement off to the side. So that's your peripheral vision, or vision at the edges of your eyes. So this is the edges of your nervous system, if you would think of it that way. So peripheral nervous system is the nerves at the edge of your, well, if you think about on the outside of your nervous system. So you have the central nervous system, and then you have everything that comes off it, or the edges. That's the peripheral nervous system. So just make a note that nerves are bundles of fibers and that connect the central nervous system with the rest of your body. You're going to learn the parts of this in biology, but nerves, they're kind of like a relay system, or kind of like a message system, where they take a message and then deliver it from one nerve to another nerve, and they can relay those messages along your body. So it's kind of like a telephone system, if you want to think of it that way, to where they are giving information up to your brain, and then your brain decides typically which information is important, and then your brain can also tell the muscles to move, and so it has to use those nerves, give the information back to them, and then the nerves will retransmit it down. So it's kind of like a mail system, if you want to think of it that way. Your nerves, these are special fibers that help transmit those messages. Those messages, though, aren't like papers. Like, I had to go to the post office this morning to mail a letter because my mom's birthday is in a couple of days. And so I had to go to the post office to mail my message to her. Now, your body doesn't run an actual paper. You don't have cells actually transmitting little bitty messages. They do it as electricity. So we call those electrical charges impulses. So instead of transporting an actual letter, they send it as electricity, telling your body to move or to not move or to gather information around you. All of it is kind of encoded as electricity, and that's what your nerves are transmitting up and down your body. So your body does have a little bit of electricity going through it all the time with your nerve impulses. Plus your brain has a lot of electricity as well. The electricity tells your heart to pump. So you still should be careful, because you shouldn't touch anything that is electrical if it's plugged in and if your hands are wet, because it can go through you, because you can conduct electricity. But you do have a little bit of electricity in your body all the time. Alright, so just make a note though that the nerves are the bundles of fibers that connect the central nervous system with the rest of your body. Those electrical messages that your nerves transmit are called impulses. So just make a note for that. That's what we call those electrical messages. Alright, impulses travel to and from the central nervous system along the brain and the spinal cord to control your other body systems. So this is what your brain does to tell your muscles to move. Remember how we're talking about the voluntary muscles? If you decide that you need to shift in your chair or at your table or wherever you're at and you want to move your leg, you have to decide, okay, this isn't comfortable, I need to move it. Whenever you do that, your brain sends a message to the muscles in your leg to move your leg and to shift it over. So your brain has to send a message to those muscles to move and to get them to shift and to move around. So your brain can control your voluntary muscles, because that's where you're thinking, and that's where you're thinking about which muscles I want to move. That's the nerve impulses that you are sending down to your body. So if you decide that you want to go get a snack, or maybe you haven't eaten breakfast yet, and so you're going to go eat breakfast now, those are the impulses that your brain sends to go tell your body to get up and to start moving. Now your brain also controls your involuntary muscles. We'll talk about this a little bit later on though. Your book points out that your body, in a lot of cases, the involuntary and the voluntary muscles, your brain does both of them. But the conscious ones, the ones you think of, are typically in that top portion of your brain. We'll talk more about those a little bit later on, because it's showing you all three parts here. You have two major different types of nerves in your head area. You have your cranial nerves, and then you have your spinal nerves. So this picture shows it, but we'll come back and we'll talk about them a little bit later for it. Let's see, I want to make sure I didn't skip anything. Nope, I don't think so. Alright, so your brain is the chief organ of your central nervous system. This is my muscle man's Ted's brain. I stole it from him, so that way I can show it and show you all the parts for it. So he doesn't have a brain right now, but it'll be fine. So your brain is the chief organ of your central nervous. There are three parts to it. You have your cerebrum, your cerebellum, and you have your brain stem. So for these are showing you, oops, I'll go back. Oops, too far. Alright, so this picture shows it to you upside down because the parts are a little bit easier to see. So if you want to look at your book, his brain's falling apart, so I'm trying to not let it fall apart in my hand. Oops, there it goes. Poor Fred. Let's see if we can put it back together. There. There we go. Okay, now it's much more sturdy. Alright, so your book showing you upside down like this is a little bit easier to see all three parts. Typically, your brain sits like this in your body though, because your brain stem is closer to your spinal cord, because that's where it connects to. So your top part of your brain, that is your cerebrum. So make a note for that. The cerebellum is the bottom portion down here. So your book describes the cerebellum as a wrinkled, fist-sized mass at the back of the brain. So make a note for this one. It's the bottom portion. If you're looking at this picture, because it's upside down, your cerebellum is right here on either side. Then your brain stem, that's the last part of your brain, and then the brain stem also connects to your spinal cord. So that way all of that is connected together. So the three parts, cerebrum, cerebellum, and then the brain stem as it comes off and as it connects. So make a note of those three parts. Alright, so the cerebrum is a large part of the brain that controls conscious thought and reason. So whenever you're thinking about following along and marking in your book, which you should be, that is the part that is thinking. So if you're thinking about life science, or if you start thinking about video games or something else, you start noticing what your pet is doing, you get your attention back to science class, so focus. But then also, that's the part where your conscious thought is what you're thinking about. That part is controlled, well, not really controlled, it's housed in the cerebrum. You choose what to think about, but the thinking part of your brain is your cerebrum. That's why if you get a concussion or if you get hit in the head, you might lose part of your memory. You might get amnesia for a short time. Typically it comes back, not all the time. Or you might have trouble remembering what happened in the last couple of minutes. That's because you might have damaged part of your brain. But again, typically that doesn't last very long and it comes back. But that's why if you get hit in the head, you gotta be really careful because you don't want to damage the thinking part of your body. So that is a large part of the brain that controls conscious thought and reason. There's two hemispheres. Kind of how like whenever we talk about the earth, we talk about the northern hemisphere and the southern hemisphere, talking about the top part of the earth or the bottom part of the earth. That's kind of like the same idea. So looking at the brain like this, trying to not let his brain fall apart. But there are two halves to your brain. Now there is kind of this central groove down the middle, and scientists have discovered that, okay, half of your brain typically does one thing, and the other half of your brain typically is responsible for other things. That's where this picture comes into play. Now, you need both halves of your brain, so don't think one half is better than the other half. You need both halves of your brain. But scientists have noticed that, okay, that the right side of your brain controls the left side of your body. So if you are left-handed, that means that the right side of your brain is slightly dominant or slightly stronger in that regard. Because if you're left hand, or if you favor your left hand more, I know a couple of you are left-handed, so because of that, the right side of your brain is a little bit stronger in that regard, just for physical motion, though, motor skills. It doesn't mean the right side is stronger in everything. For those of you that are right-handed, so I'm right-handed, that means that the left side of my brain is a little bit stronger in that regard. Now, it's a little bit weird how the right side of your brain controls the left side of your body, and the left side of your brain controls the right side of your body, but that's just how it works. So now, you do need both sides because you have to do things in both hands. But in some cases, one side of your brain is typically stronger for the idea of motor control if you're right-handed or left-handed. So if you're left-handed, that means the right side of your brain is slightly stronger in motor control. If you're right-handed, that means that the left side of your brain is slightly stronger. Now again, you need both parts. Scientists have discovered that the right side of your brain typically controls things like, we would say, artsy type things like imagination, awareness for like doing art. You're aware of what music is and rhythm and how it works together, three-dimensional perception, intuition. So something we would describe as like an art or having like creativity, we would describe that as more of a right side brain thing. Now, Now, don't think, oh, that's just the fun side of my brain. No, because you need both sides. But this one, this is why sometimes people, they struggle with hearing rhythms, or they struggle with seeing how art, with the colors, how it works together, whether or not it looks good or not. That's part of the reason why, because they just might not be very strong in that area on the right side of their brain. The left side of your brain, we would say, has to do with more of logic and learned skills. So understanding your science skills, so as you're working on your STEM papers, so again, it's just the background right now. But as you're thinking through over logically how to test your experiment or how to come up with a demonstration, that's the idea of a science skill, coming in with the logic idea of, okay, I'm going to do this step, and then this step, and then this step, and then this step. So using that logic side of your brain, that's part of the left side of your brain. So logical thinking, science skills, written language, mathematical ability. So thinking through how to solve a math problem or how to write a sentence. What's the subject? What's the verb? What's the predicate nominative? So all those things in English class. So that has to do more with the left side of your brain. Spoken language, how to form sentences. Now, you might think, well, I'm not very good in math and I'm not very good in English, so the left side of my brain must not be very good. Okay, no, so this does take time to learn and it does take a while to practice for it. But it's the left side of your brain that basically does that type of it. Now, don't lose hope if you're not very good at math or English. It takes time to build that up. But that's that's more of a left brain thing, where that does the idea of doing a learned process and trying to connect the ideas together. Now you need both. So if you want to write a story, or if you want to paint a picture, or if you want to build a sculpture, you have to visualize it and know what it looks like, or use your imagination. So you have to use the right side of your brain. But in order to actually make it, actually write it out, or actually draw it, or actually build it, you need the left side of your brain to actually do that. So you need both sides. So it's not like one side's more important than the other side. You need both, so that way you can build art, you can write good stories, you can talk to people, you can carry on conversation. You need both sides. So both sides are important. So don't think one side's better than the other. Nope, you need both of these for life. Just make a note though for those. Let's see. Alright, so that's the main thing with the cerebrum. So talking about the right and left side of the hemispheres of the cerebrum. Getting back now into the cerebellum, these portions down here. So remember, this is your cerebrum with your conscious thoughts. So make a note for those. Cerebellum coordinates your muscle movements and it remembers how to do them. So your book points out, your cerebellum is a wrinkled fist-sized mass at the back of the brain below the cerebrum. It is responsible for balance and skeletal muscle coordination. So, whenever you thought about standing to go get a drink of water, you did not have to remember how to move one leg, how to move the other leg, go back to the first leg, go back to the second leg. You just thought, I want water, and then stood up and went to the fridge or went to the sink. You didn't have to think about how to walk. That's because your cerebellum remembered for you, I know how to walk. And so now that they want to move, I will help them, and I will help them remember how to walk and how to get there. So your cerebellum helps your body to remember muscle movement. This is one reason why whenever you are writing down, so hopefully as you're marking your book, but as you're writing as well, you don't have to think, how do I make an A? How do I make a B? How do I make an E? You just start writing, because your cerebellum remembers how to form those letters. That's why you practice so much in kindergarten and first and second grade. So that way you're teaching your cerebellum how to make these motions, and then once your cerebellum's got it and remembers, you don't have to think about it anymore. Same thing with swimming. Whenever you were learning how to swim, it was typically really hard at first, but now you don't only have to think about it if you've already learned how to swim. For your skeletal muscles, your cerebellum remembers how to do that, and you don't have to think about it as much anymore. As I mentioned, Tadasky makes you practice. I don't think you've done softball yet. I think that's in the spring. The reason why I mentioned Tadasky makes you practice over how you stand and how you swing. So that way, once you learn how to do it properly, your cerebellum will take over, and you don't have to think about how to do it properly anymore. You'll just do it. So that's nice. So that's your cerebellum. Your brainstem, make a note for that one. That connects the brain to the spinal cord. It's responsible for the body's automatic nervous system, including digestion, heartbeat, breathing, and regulation of the body temperature. So regulation of your body temperature. Your brainstem does a lot of your involuntary muscles. So your brainstem tells your heart to keep breathing. So So this is good though, because whenever you fall asleep, your cerebrum in a lot of cases kind of shuts off or turns off, so that way you can go to sleep. Now you're still dreaming in a lot of cases, but your brain is resting, and that's why you need to go to sleep. Your brain stem keeps going and tells your body, the heart to keep pumping and for you to keep breathing. And if you ate a late night snack, your stomach and your intestines will still digest it. It keeps going, whether or not you are conscious or awake or not. It just keeps going for you. So that's why whenever you fall asleep, you don't stop breathing and you don't die. It's because your brain stem keeps telling you to keep going, and it keeps sending out those impulses, telling your body to keep going with those important functions. So make a note of that it controls the body's automatic features or automatic activities like digestion, heartbeat, breathing, regulation of body temperature, keeping it at that 98.6 or slightly lower typically today. Just make note that those are the three parts of the brainstem and what they do. So cerebrum, conscious thought and memory, so make a note for that one. It controls conscious thought and reason. Cerebellum, the skeletal muscle coordination. Brain stem, this controls your automatic or your voluntary automatic activities of your body, or those involuntary muscles. So those are the three parts of your brain. Be sure to note them and to mark them. Alright, your book points out you have your spinal cord as well. That's the other major organ of your central nervous system. So you have your spinal cord. So that one is housed in your vertebral column. It's supposed to be there, so that way it is protected. Now, your spinal cord though doesn't just relay information, it also acts like a watchtower whenever you have a reflex. So whenever you have, so let's say you touch something really, really hot, so you accidentally touch the stove. Now, the nerves in your skin notice, this is really hot. This is too hot actually. Your skin is getting burned and damaged and it hurts. So they send a message to your brain basically saying, pain, you are hurting your body, you need to do something. So that they send the messages of pain, 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 you need to do something, pain, pain. Now if you had to wait for it to go all the way up to your brain for your brain to notice, I have pain in my finger, I should move my finger. Finger, move. Finger, move. And it sends that impulse or that message all the way back down, a finger move. By the time it got to your finger would be crisp and it would hurt really bad. You would probably have a third-degree burn by this point. So because of that, your body is designed to where it kind of do like a shortcut system. This is why if you touch something and it sends pain, something's hurting your body, and it sends it, your spinal cord notices, that message said something was wrong. It was a pain message. I'm not going to wait for the brain to send the message to move the finger. I'm going to go ahead and just say, go ahead and move. So your spinal cord will go ahead and send a message, move finger now. And that's why if you touch something hot, and you might not even realize that it hurts yet, but you'll notice it and you'll jerk away. Typically it's kind of a spazzy jerk and it's not very coordinated. That's because your spinal cord isn't like your brain where it can organize how to move. It's just saying move now. That's why it's kind of a jerky spaz whenever you jerk away from something that's hot or something that's cut your hand and you just jerk back from it. That's the reason why. We call those a reflex, because it's your spinal cord that's saying go ahead and move. Doesn't have to be coordinated. You don't have to use the cerebellum to make it nice and smooth and coordinated. Just move, get it out of the way, so that way it's no longer getting hurt. So those are reflexes. So you better point out whenever your hand touches a hot object, the spinal cord, not the brain, sends the messages to your muscles to move away. So that's why it's always kind of a little spazzy jump whenever you are reflexing away from something, because it's your spinal cord that's sending the message, not your brain. That's also why typically once you've already jerked back, then you notice, oh yeah, I hurt my hand. Oh, I should go put ice on it. So you might not even realize how bad you've hurt it yet until later. That's the reason why your hand will jerk first before you fully realize, oh, I've cut my hand or I've hurt my hand. Just because your spinal cord is already sending that message before you fully got to your brain. Alright, so just make a note of that. So those are reflexes, and those are with your spinal cord, not with your brain. So you have your spinal cord, that's the one that does the reflexes for you as opposed to just your brain. Alright, so watchtowers and relays. There are two major parts of your peripheral nervous system. So talking about the nerves that come off your brain and the nerves that come off your spinal cord. You have cranial nerves, so kind of like talking about your cranium or your brain case. Those are the nerves that come off your brain, so those are your cranial nerves. Your other nerves are your spinal nerves. So you have the nerves that come off your spine and the nerves that come off your brain. Your book points out that you have 12 pairs of cranial nerves. These typically affect just your face area. As a side note, they affect your head and face area. There's a couple of nerves that are special that go down farther, but those are mainly your cranial nerves. They color them kind of a greenish color in this picture to make them stand out a little more. But those are your cranial nerves. Alright, it looks like I'm just about out of time, and since I gave you classwork, I'm going to start off a little bit early so that way you feel like you have time to work on that as well. So make sure you're using your time properly so that way you're studying and getting ready for any quizzes that are coming up. Also, don't forget you have a test or your exam next week, so make sure you're studying this. You don't want to get overwhelmed. So thinking back over it really quick, what are the two parts to your nervous system? Hopefully you remembered, okay, central nervous system, that's the brain and spinal cord, and then the nerves that come off of it, those are the peripheral nervous system. Alright, what do you call the parts of your nervous system that actually transmit the messages? So they're like the relay system where they're sending those messages. Good, those are the nerves. What do you call those electrical messages that the nerves send? We don't call them messages, there's a better term for them. Impulses, perfect. Alright, thinking about your muscles, what is the muscle in your shoulder area? You might have to cheat and look on page 95, but you need to learn these. Deltoid. What's the muscles of your chest area? So if you're pushing something away from you. That's your pectorals. What is the muscles in your arm, the top part that pulls your arm up? Biceps brachii. What's the bottom muscle then that pulls it back down? Triceps brachii. What do you call the anchor point for a muscle? Origin. And then what's the part that pulls the arm or pulls your leg? What do you call that point where it's pulling the bone or moving the bone? Insertion. Remember, insertion always moves towards origin. Let's see. What do you call something that connects bones to bones? Bones to bones, not bones to tendon, not bones to muscle. Bones to bones is ligaments. So remember, bones to muscles, that's tendons. So don't get them mixed up. You want to keep both of them. Alright, those are the major things we've talked about today. Oh, 3 parts of your brain, really quick. What do you call the top part? Does conscious thoughts and reason. Cerebrum. What's the part that does skeletal muscle coordination? Cerebellum. What's the part that does automatic processes of your body? Brainstem. Perfect. So make a note for those things. We'll talk more about the spinal cord. Kind of have to be a little bit quick today, so we'll come back and talk to it tomorrow. Make sure you are studying, keeping up with it. Alright, I'll go ahead and let you go. Your homework for tonight is to read pages. It's going to jump forward a little bit, so don't get too alarmed by it. So we're going to have to jump forward just a bit. So read pages, let me get to the proper spot, 102 through 104, 102 through 104. Answer on page 104, questions 12 through 15. So answer on page 104, questions 12 through 15. Don't forget, the second draft of your background paper is due tomorrow. I've already emailed your parents over what to do for that, but make sure that you have either a copy of it or you have it on your computer screen or something to where you can look at it as we talk about what you need to fix at the same time. So make sure that you have either a printed copy or you can just have it on your computer screen so you can look at it and look at me at the same time. Because we'll talk about kind of like an in-class workshop tomorrow over what you can do to fix it and how you can make it better for your final draft coming up. Alright, you guys have a great day, and you will see me tomorrow, but I will see you hopefully soon.